All right, now we're going to talk about evaluating expressions. Evaluating expressions means that you have a variable expression with an unknown value, and you're told to go ahead and replace the unknown value with something that they give you. So for our first example, it says, what is 5 times x when x is 3? We're going to take that x equals 3 and just substitute it into our expression for x. So I'm going to show it rewritten this way. I have 5, and we're going to plug in 3. And I plug in my variable or my given value in parentheses so you can see exactly what I'm substituting in. This also helps when we get to powers and maybe we're plugging in negative numbers and we have subtract a negative. This just kind of helps keep it clean when you're writing out your work. So I've got 5 times 3, which is 15. Next expression, r minus 3 when r is 7. So go ahead and replace the r with 7 and then complete your work. So the evaluating part is not only the plugging in, but then the actual doing of the operation in your expression. So 7 minus 3 is 4. Next we have a power. So we've got a base of k, a power, an exponent of 4. So when k is 2, we're going to go ahead and plug 2 in for the base to the 4th power, which means we can write it out as a string of multiplication. The base gets written 4 times, so then we're going to do 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8, times 2 is 16. Next one, my division sign kind of disappeared there. So I have 24 divided by f. It's a fraction. Remember that fraction bar means division. We're going to divide the top by bottom. Numerator divided by the denominator. When f is 8, so we're going to go ahead and rewrite 24 divided by, and we're going to plug 8 in for our variable. So 24 divided by 8 is 3. Next one, we have 3x minus 2 when x is 4. So we have 3. Go ahead, plug in 4. Minus 2. And this we have to use our order of operations with, which is in our video here. So let's see. We have 3 times 4 comes first. 3 times 4 is 12. Minus 2 gives you 10. And then you have this last expression. It says, whoa, let's come back to this one. And that's because you need the order of operations for this. So we will go ahead and pause on that one and move on, and we'll come back to that example. So go ahead and pause your video and go ahead and try these 4 examples for me, please. Now that you've tried these examples, let's go ahead and see what the work looks like. So we're going to go ahead and 15x when x is 4. We're going to plug 4 in. And now we evaluate, which means complete the operation. So 15 times 4 is 60. Next, we have 0.4, or 4/10, times 6, which is 2.4, or 2 and 4/10. Next, we have 2.5, or 2 and 5/10, times 4. This gives you 10. And then we have a power. So we have x to the 3rd power, or x cubed, when x is 3. So we're going to plug 3 in for the x, and we have to cube it. So again, I'm going to show it as an expanded form of multiplication, so you get used to what the power and the exponent look like. But we have 3 times 3, which is 9, times 3 again is 27. So those are your examples for evaluating expressions. We're going to kick it up a notch and take a look at the order of operations. So when we look at this example that we had on the previous screen, 3 plus 4, x to the 3rd minus 6 divided by 6, there's a lot of operations there. There's addition, subtraction, division, multiplication, and an exponent. What do we do first? By convention, we use the order of operations. So the order of operations tells you exactly the steps that you need to do in the order that you need to do them for every math problem that you come across. Our order of operations is GEMDAS, the acronym, and it stands for G, groupings. Groupings could be parentheses. They could be those little squared off brackets. They might be the curly brackets or braces. They're also the fraction bar. The fraction bar represents a grouping of the numerator and then the denominator. Our next step is exponents, the E for exponents. This could be, again, your base to a power, but it also could be a root or a square root or cube root for our class. So this could be a square root of something or a cube root of something. That also falls in that exponent line. Our next step would be multiplication / division, and this is based on the order you see it from left to right. Once you've done your grouping and your exponents, and then you look to your problem and you say, oh, I have multiplication and division, which one do I do first? You do what's to the right first and then to the left. We're going to read it from left to right. And our last step is addition and subtraction, and again, we read it from left to right. So you do whatever's on the left first and then move through to what's to the right. So which evaluation is correct? What are they talking about? They're talking about this example up here. So let's take a look. We're going to go ahead and rewrite our expression with our plugged in value. Whoops, that's not our plugged in value. Let me go back a second. 4. And we're going to plug in 2 for the base minus 6 divided by 6. So that's our just substitution. I should see that for every math problem. Go ahead and show me how you're substituting in your numbers. Then we're going to start evaluating by G, groupings. The only grouping I have is 2 in parentheses, and that was just our plug-in value. So there's nothing to operate there or evaluate. So I'm going to move on to exponents. I do have an exponent, 2 to the 3rd power. 2 to the 3rd power is 8. So I like to rewrite each step of my work. So you'll see I've just done the 2 to the 3rd power is 8, and I'm just rewriting the rest. Next, let's go ahead and take it over here. After exponents comes multiplication and division. So I'm going to read it from left to right. So I see some addition. I don't do that, but I do have multiplication. So I have 4 times 8. That's 32. Minus, and then I have 6 divided by 6. 6 divided by 6 is 1. So that was my multiplication and division in the order that I see it from left to right. Then we're going to go ahead and do our addition and subtraction. So again, I'm reading it from left to right. The first thing I come across is the addition and then the subtraction. 35 minus 1 is 34. So this is the evaluation that is correct. How will you remember the order of operations? Will you remember GEMDAS, or will you come up with some other acronym or poem that helps you remember the order of operations? Let's take a look. We've got some more examples to try. So I'm going to go ahead and make my screen a little bit wider. And go ahead and pause the video. Try out these examples and then check back in and see how you did. Okay, now that you've gone ahead and worked out your examples, let's see how you did. So first things first, it's just evaluating for these top 4 problems, which means go ahead and complete the math in the correct order using the order of operations. So first things first, I don't see any grouping, but I do have exponents. So I'm going to go ahead and evaluate. 4 to the 2nd power is 4 times 4, which is 16. And it says times 5 minus, and 6 to the 2nd power, 6 times 6 is 36. So the next thing I want to do is go ahead and use my order of operations to come up with my multiplication, which happens next. 16 times 5 is 80 minus 36 gives me 44 for my answer. Letter B, 20 minus, evaluate your base with exponent, 3 to the 2nd power. 3 to the 2nd power is 9 plus 7. So 20 minus 9 is 11 plus 7 gives us 18. Notice that I didn't do negative 3 to the 2nd power. right up here. If I had the negative 3 in parentheses raised to the second power, then I would be saying negative 3 times negative 3, which would give me a positive 9. But my example was minus 3 to the second power, so just the 3 gets raised to the second power. We'll do more with powers and exponents in upcoming units. Next, letter C, we've got 5 times 2 to the third power is 8 divided by 6. Order of operations, multiplication and division, but remember in the order that you see it. So 5 times 8 is 40, and then it says divided by 6. Don't jump to your calculator. Hopefully you're noticing that this is not going to divide evenly and you're going to end up with a decimal. We're going to, in algebra, we're always going to leave, rather than changing it to a decimal, we're going to leave it as a fraction. And what we want to leave it in is an improper fraction. We don't want to see mixed numbers in algebra, so don't worry about moving it to a mixed. We're going to leave it as an improper fraction. So what do I do here? Remember that your division sign is another representation of a fraction bar. So I'm going to read it. 40 divided by 6. Well, that's the same thing as 40 divided by 6, fraction bar. So again, we talked about how 40 can't be divided by 6 evenly. So is there something else I can do with this fraction to make sure it's in perfect, pristine, simplified final answer? And the answer is yes. You can go ahead and divide top and bottom by 2 to reduce or simplify your fractions. So I'm going to go ahead and divide the top by 2 and the bottom by 2. I'm reducing my fraction. 40 divided by 2 is 20, and 6 divided by 2 is 3. Oops, I wrote a 2 there, is a 3. So 20 divided by 3, or 20 over 3, is my final simplified answer. It's my fraction. And we love that. Leave it. Improper and all. Leave that improper fraction. All right, let's go ahead and take a look at letter D. I've got some parentheses now and brackets. So when you're working with 2 sets of grouping symbols, you always work on the inside first. So I have 6, and then I have 2 to the third plus, in parentheses, 13 minus 8. That's what we're going to do first. 13 minus 8 is 5. Okay, we're still working within the groupings. So in that grouping symbol, I see an exponent, I see addition. We're going to go ahead and do the exponent first. 2 to the third power is 8 plus 5. That's in my grouping. What's 8 plus 5? That's 13. And then I'm going to lastly multiply, and we should come up with 78 for an answer there. All right, let's take a look at the bottom 3. These are evaluating, so this is when we plug in. So we're just going to go ahead and first plug in, and then evaluate using your order of operations. I'm going to move a little bit quicker through this since we already talked about the order of operations, and we should get negative 10 for that one. Next, we have 2, plug in 9 to the second power minus 15. 9 to the second power is 9 times 9, which is 81. Two times 81 is 162. And then we're going to go ahead and minus 15, and we'll get 147 as our answer. All right, so the next one I started working out already. So I've got 5 times 9, which is 45. And the bottom, 9 plus 6. 9 plus 6 is going to be 15. So I have 45 divided by 15, which is 3. Let's take a look at the last example. I have 5 plug in 9 minus 1/3 plug in 9. So from here, what I've done is 5 times 9 is 45. And to get my multiplication over here, I put a 1 under the 9. And we're going to multiply straight across the top. 1 times 9 is 9, and 3 times 1 is 3. Then we're going to go ahead and do, let's see, subtraction or division. Division comes next. So 9 divided by 3 is 3. And we'll have 45 minus 3, which gives you 42.